Eiger allows us to be able to control any kind of printer or any kind of 3D printing additive asset that we have on the network. So in our case, it's going to be a metal printer, it's going to be a carbon fiber composite printer. On the carbon fiber composite printers, this will control the industrial printers as well as the desktop printers. And the way that it works is quite simply, I open up an STL file. So this is the impeller that was created for us in CAD. In CAD, we said File, Save as STL. In Eiger, we said File, Open STL, and it brings it into our view like this. The grid on the bottom represents the print bed. And then I select the material that I want to print it out of, and if I want any reinforcement material, any carbon fiber or continuous fiber reinforcement material. What the internal view looks like. So if I had the ability to do an X-ray view of the part, this is exactly the way that it would look, and allows me to see the architecture of the part, the infill. I can view the part layer by layer. See layer by layer, here's exactly what the toolpaths look like, including the infill. I can go back to my 3D view. Now, let's say that I want to add some continuous support to the part. So I'll view this version of the part where we did add some continuous carbon fiber reinforcement. And under the reinforcement settings, we said, well, we'd like to have 50 layers of continuous fiber, and we'd like that laid up concentrically. So if I look at the internal view, it'll allow me to see, here's the way that we've got the part or the continuous fiber laid out inside of the part. So in this example, I did it concentrically, and I also did it isotropically. So across this base, you can see the isotropic pattern, and you can see concentric around the outer walls and the inner walls. So I can control exactly where the continuous fiber reinforcement gets placed on the part. Today we're going to focus on metal. We'll also talk about the carbon fiber composites technologies. So this printer is known as the Metal X. The Metal X prints about 7 or 8 different metal materials ranging from A2, D2 tool steel, Inconel, stainless steel, copper, and we'll very soon be printing titanium. The process that we employ as part of the 3D printing process in metals involves really kind of 3 steps. Step 1 is that we print the part into, generically we'll call it a green state. The process that we have encapsulated in 3D printing technology in the past came out of the castings industry. A lot of people knew it as MIM, M-I-M, which is for metal injected molding process. So the way that that process works is that we start with a powdered metal that is formed into a filament. The filament has 2 binders attached to the filament. In our case, the first binder is wax. The second binder is a polymer. So we 3D print the part into, again, generically we call it a green state. That's step 1. Step 2 is that we wash the part. So by washing the part, we're removing the first binder, that being the wax. And then the third step is sintering the part. So when we sinter the part, which is about a 24-hour cycle, the sintering process removes the second binder, which is basically a polymer. After we have removed the second binder out of the metal part, the part has been fused into a solid 97% dense part that meets our material specs. So we're going to talk about that process here in a little bit more detail. On this side, this is one of our industrial printers. This is a carbon fiber composite printer. It's known as the X7. It's an industrial X7. The industrial X7 is a larger format printer. The space volume inside of the X7 is roughly a cubic foot. So we can print fairly large parts, carbon fiber composite. So by that we mean we're actually printing 2 materials at the same time. With the carbon fiber composite, we're printing a base material, and the base material kind of looks like this. This black material, we call it Onyx. Onyx is a combination chopped carbon fiber material combined with nylon. So it forms a very, very strong part. At the same time, we can print continuous material, and the second material that we can print can be one of 4 different materials. So the 4 different materials can be carbon fiber, they can be Kevlar, they could be fiberglass. We also have a high strength, high temperature fiberglass as well. Desktop printer can print two materials at the same time, basically the same materials as the X7. The X7 does introduce a couple of new materials that we don't support on the desktop printers. The last step in the process, it is kind of optional. It's a kind of a QA/QC process that we employ here in our lab, is that we utilize 3D scanning to be able to measure the parts. So what we have the ability to do is take the physical part, we can 3D scan the physical part, and then in software we can call up the CAD version of this part. We can overlay the 3D scan of the part, and literally within a minute or two we can tell you if the part physically matches the CAD. So we got out of the sintering oven through the entire printing process exactly what we expected, or if the part is deviating a bit for whatever reason, where is it deviating and how much are we deviating?